Hello guys, let's gather some viewers first, then we will start our stream today. Okay, okay guys, today we will be learning about decision making in Python. Let me open our new folder here. Part 4. Okay, opening Visual Studio Code, and then let's make a new file called, so it's part 4, right? Let's say part 4.py, and let me open up a terminal in here. cmd. Yes, here we go. We've got our terminal. For Linux and Windows users, you can just use your respective shortcuts or your options. Okay, how many viewers we got? Let's see. Yeah. And today we were going to learn about some decision making in Python. Let me increase the font size. Decision making. So by decision making, we mean if and else statements, and also this decision making is an important part of programming, of course, because using this we can determine whatever code we want to execute if a certain condition is met. So if we will first discuss if statements, then if else statements, then we will talk a little bit about nested statements, nested if statements. Okay, no more viewers, I guess. Let's see. Let's wait a little bit and gather some viewers. Meanwhile, Let me open up the Python interpreter in my terminal. You can type Python 3 in Linux and Mac. All you got to do is type Python 3 in a terminal. But for Windows users, yeah, Python should do. Okay. I guess we're not getting any more viewers now, so let's get started with our if and else statements, also known as decision making. Let us first discuss the syntax of our statements. I think I closed it accidentally. Okay. Now let's say if now here's the syntax. If something condition, this is just a placeholder for a condition, and generally what happens in this line in this place is that we check for some condition, and if the condition is true, then if the condition is true, then the code below gets executed. And we also talked about indentation, so I'm given 4 spaces. I could also give a tab, and everything that has to be inside this, if every statements that have to be inside this if block should be inside the same indentation. For example, statement 1, statement 2. However, if it goes out of indentation, then it, so they have same spaces, right? They have same spaces, 4 spaces or a single tab in my case. And statement 1 and 2 are part of the block of if condition, but statement 3 is an independent statement because it is not a part of this if block, because we have not indented it properly. What if it were like this? It would also come inside this block. Okay, this is just like giving curly brackets in any other programming languages such as C, but in Python there are no curly brackets to determine the block, so we use indentation. Now here what we get, here what we write is any condition that we check to get either true or false. If the condition is true, then the statement 1 and 2 will get executed, otherwise they won't be executed. So we're providing the program, we're providing our interpreter with a condition that these two blocks of code, these two statements or this block of code have to be executed only if the certain condition is true. Well, like we discussed about conditional, sorry, not conditional, comparison operators in our previous part 3. This could be for example, if a equals to b, right? It could be like that, or it could say if true, then we this, if false, then do something else. Let's see. Let's do it first. And okay, let me take an input. Okay, is equals to input enter value of a, and it will take a value. So value of a is going to be 5. Mm, same goes for b. Value of b is going to be 5 too. Now I'm going to compare them. Okay, if a equals to 5, then sorry, print a is equal to 5. Well, this is a pretty bad example. Let's just write a script in here. So in part4.py, we have part4.py, where we will try to run that, execute that script. Also again for Linux and Mac users, you have to do this Python 3 part4.py, and Windows users can just do this, because our terminal is pointing to our current respective folder, part4 folder. So let's write a script. A will take input from the user, enter value of a. Now let's take another value b. Now we will use the if statement, right? If a equals to b. Well, you have two options now. You can either choose to enclose this inside this, between these two small brackets, or you can just choose to keep it open. That's your choice. Now I will give proper indentation, 4 spaces or a tab, and I'll print a is equal to b. Now let's run the program. Like, we will first take inputs from the user, then we will compare the two inputs and uh, print the string that a is equals to b if both of them are equal. So part4.py, we already have that. We enter the value of a. Let me enter 5, and b also 5. Yes, a is equals to b. Now let's run that again with different inputs, 4 and 5. We print nothing here because a is equals to b. When I supplied a equals to 5 and b equals to 5, then this 5 equals to 5 is going to return true, right? 5 equals to 5 is going to return true, but 4 equals to 5 is going to return false. Since this statement gets executed only when the following condition is true, and the following condition is true only if both the inputs are same, then we get this print or this output when we supply the values of a and b that are equal. But we won't get any output if we supply unequal values of a and b. For example, if I supplied 4 to a and 5 to B, then 4 is equals to or 4 is equals to 5 is going to return false. Thus this statement will not be executed. Okay, now what if I want to check, what if I also want to display that if A is not equals to B, then if A is equals to B, we have already printed that in case A is equals to B, right? Now what if we also want to print another string? For example, if I want to print whether A is not equals to B, so it's pretty simple. We first check for whether A is equals to B, right? And then we will print A is equals to B when this condition is true. But we will use else now and print A is not equal to B, because it's the other condition, right? If this does not meet, then obviously this condition has to be run. This condition becomes true and this statement is run, right? Let's run this. Okay, p part 4.py into the value of A 5 5, A is equals to B. Okay, 4 5, A is not equals to B. Yeah, obviously, because if A is not equals to, if A is not equals to B, then this statement will not be executed. But else, if this is not true, then execute this statement. That is the gist. Okay, you have to understand it in a simple way. If this statement is not true, then we have to run this statement, this block, right? Well, that's if and if else for you. In if, we only provide this block. This block will get executed only if what this this block will get executed only if this condition is true and there are no other conditions to look for, no else, nothing else. It will either print this string or it will not print anything at all. Okay, we can also use only if A is not equals to B, then print A is not equal to B. Now we can have multiple inputs, right? So if 5 equals to 5, then this will be printed. But if we provide 4 and 5, then this will be printed. A is not equals to B. A is equals to B, right? Now instead of writing this whole condition, we can just use else in here, because if one is false, then other should be true. It's the same thing now, but in a more efficient way. 5 5 4 5, yeah. Now we will use something called else if sorry, we will use something like else if we come from uh, you know, C or C++ background, then you might be used to this, but in Python we use elif. Now what happened, now what generally happens is, in else it does not check for any condition. This block gets executed if none of the condition match. This is the, this statements get, this block of statements inside else gets executed only if the whole conditions do not match. Okay, but what if you want to check something? Let's say if I want to check whether A is greater than B or A is less than B, then we use else if, because in else if we can provide it with some conditions. Okay, now let's see. Else, okay, we will keep this else. We will use elif. The condition should be, this is exactly like if, just we use elif, so that if this above statements does not get executed, then it will check for this, and if this does not get executed, then it will check for this. Now elif a is greater than b, right? If a is greater than b, what we have to print? That a is greater than b. And let's also check if a is less than b. Elif a is less than b, print a is less than b, right? Now what happens here is our Python interpreter first goes through this condition, right? Now if this condition returns false, then this block will not be executed. Now since we have elif, it will move to the next block, next condition. If a is greater than b, then it will print this line. But if a is not greater than b, then it will not execute this line and move forward, right? It will go here. Now if a is less than b, it will print this block, and if this statement also returns false, then final block of statement that will get executed is else, and it takes no conditions. This is the last condition. This is the last block of code that gets executed when none of the conditions match. Now let's save this and let's run it. Part4.py. Now let's say 5 and 6. Yes, here a is less than b because 5 is less than 6. Let's say 8 and 4. Here a is greater than b because 8 is greater than 4, right? Let's say 5 and 5. A is equals to b, and 6 and -1. A is greater than b, right? Well, actually this will not be executed because a number is either greater than or smaller than or equals to, so we don't need this anymore. But if there is anything if you need to put a block of statements which you need, if none of the conditions match, then you have to keep it inside this else statement. Okay, well, that's it for if and else and else if. Now let's talk about nested if. So what are nested if statements? Well, by nesting it just means if statements inside an if statement. For example, if I write an if statement, okay, no, let's it nested if are just if statements inside an if statement. So if I write another if condition and then statement inside this, inside the block of anything, and it's going to be nested else nested else if statement. Okay, nested if. So I'm giving and I have to give an indentation here too, because now this block is going to be executed if this condition is true. Now let me show you in a simpler way. Let's say if condition is true, then statement 1 will get executed. If condition. Now this is inside. Now we have given same amount of indentation, right? That means these two are this the part of these two block of statements are part of this if condition, right? Now statement 2.1, because since we separate the block of code by using the indentation in Python, right? We use indentation to separate whether it is a part of the block or of statements or not. So I have to give another indentation. Here we will give statement 2. Now these two statements are part of this condition, while this condition is part of this condition. Now let's say if condition. Now I will have to give another line of indentation here. Statement 2.3.1. Well, this is an example of nested if statements. An if statement inside an if statement. We could also do the same thing with elif, else if. And let me copy and paste this. Indentation is very much needed in Python, so you have to be careful about them, otherwise you might get unexpected errors. And these could also have elif inside them. Right, like this. Now this elif is going to be part of this because you can see the indentation, they have same spaces. Now this elif is going to be part of this f because of the indentation. Right? Yeah, so this is a general example of nested if statements. Now let me show you a working example. Let us do that same comparison we did in another way. Now if a is not equals to b, then it should be either greater than or less than b, right? Let's write the program first. And if a is greater than b, print a is greater than b, else sorry, elif b is less than a, print sorry, a is less than b. Now we can use else here. If a is not equals to b, then this will get executed, right? Now else, if a is not equals to b is false, then that means a is equals to b. That means a is equals to b. And if A is not greater than B, okay, now let's first run this, otherwise it will be more complicated for you. Now let's 5 and 5, A is equals to B. 4 and 5, A is less than B. 6 and 5, A is greater than B. Now what happened here? At first our program will check if A is not equals to B. Let us suppose I supplied A equals to 5 and B equals to 6. That means 6 is not equals to B is a true statement. Let me show you in the Python interpreter. 6 is not equals to B, which is 5, is going to be true, because 5 is, because yes, 6 is not equal to 5, right? But if a number is not equals to the same number, then it should either be greater than or less than, right? So 6 should be greater than 5. So now we will be checking for that condition. This is true, this was true. Now we will move inside. Now if A is greater than B, now 5 is obviously not greater than 6, which means this will not get executed. Now we will move further down. Else if A 5 is less than 6, which is true, now this will printed there. Now this will be printed and the program ends, because once we go inside a certain decision, if I go inside this, then this will not be executed, or it will be if the condition matches, right? Now what we can do here is, if A is not equals to B and this happens, then obviously we can just use here else, because they will be equal, right? A is equals to B. If A is not equals to B, then this. If A is equals to B, then this. Now here also, a number can, if a number is not equals to the number, which is true, then obviously we can only check one condition, whether if it is greater than. If it is not greater than B, then it is less than B, so we can use else in here. Let's say part 4, let's say 5 and 5. Okay, what happened here? Less than B. Okay, my bad. We do have to check in here. I completely forgot about that, because if it's not equals to this, then there might be a mistake. Let's see. Okay, well, this is happening because we hard coded the values in here. Silly mistake. Let's say 5 and 5, it is equal, let's say 6 and 8. 6 is less than 8. Now it's working, guys. Yes. So nested if else and if else if elif. Now you know about that. Let's make a simple program that takes the input from the user, and while it calculates, it shows you the result, whether if the voter is eligible to vote or not. I mean, the citizen, right? Let's say the voting margin is 18. If you are, if your age is greater than 18, then you are eligible to vote. And if your age is not greater than or equals to 18, you know, let's say age input, sorry, not input, enter the age. Now we will check if age is greater than 18, greater than or equals to 18, we will print eligible to vote. Eligible to cast vote, right? Now else print eligible for voting. Let's run this. Let's say 21. Okay, so what happened here is, let's read this error. Type error. Greater than or equals to is not supported between instances of string and integer. So what happened here is, when we take the input, by default Python takes that input as integer, as string. And since we do not specify what values or what data types we will be taking, we will have to use something called typecasting. So generally typecasting means changing the type of a value. For example, if this is an integer, if 5 is an integer, and if I want to change it into string, then I will use typecasting to change this 5 from integer into string. And the syntax is, if I want to change 5 into string, right, so I use str and double, and I know that opening and closing small brackets, and inside them I will pass the value, so 5. Now this 5 will be converted into a string 5, not an integer 5. This will be a character instead of a number. Now if I want a string to be converted into a number, now let us suppose if I and t, now strings are written inside double quotation, right? So I will give double quotation. Now if I do this, the 5 which is in character form, in string form, will be converted into a number 5. So the input is taking our input as string. Now we have to convert it into an integer. Now what I will do is just use type conversion, and inside this int, this typecasting, we are changing this input into a integer. Now if I run the program, there should not be any error, because by default we are using integers, which is a number, and we can easily use comparison with integers. Let's say, yeah, 21, eligible to cast vote, because now the program is taking this input as a, how do you say that, uh, as a number or as an integer. Okay, that solves our first problem of the day. What if I did 18? I should be eligible, right? What if I did 12? Not eligible for voting. Simple as that. Okay. Now, after we've completed decision making, this is all that is that exists there decision making in Python. Decision making, we learned about if statements, if else statements, elif, and nested if statements, right? Now, have a little, if you have a background in coding, then you should also know about something called switch statements. But Python does not provide any implementation of switch. The switch keyword does not exist in Python, and neither does switch function exist. So what we do? Let's try to create our own version of switch. So let's say what happens in switch case statement is that we select a certain value. Let's say I have a variable a. Now we select a certain variable a and check for the values inside this a. Now for example, we'll do switch a if in C++. Okay, we will select, if we have declared a variable named a and assigned some variable value to it, let's say 51, 2 or 3 or something like that, then we will select the variable, and if the value inside this variable is suppose 1, then we will execute this lookup statement. And if the value of a is 2, then we will use this, and just like that it will work. Now let's implement this in Python. Okay, now let's define something called switch, and pass an argument in the function, and let's make a dictionary. It's like case. Okay, uh, case is, now if the case, we will use the key and value method. Okay, now if the value inside I is an integer 0, then we will print case 1 or case 0. If it's 1, then case 1. 4, 5, 6, 7. Now let's just do it till 7 cases. So we made 7 cases, right? Then we will be returning the output of this cases dot get function to get the value, or we could just use this let's call switch and pass value of 5, then this should print case 5. Okay, it did not print anything because we are not using the print statement. Case 5. Yeah, it's simple. So here we go, we have implemented our switch case. We can use get and let's provide the key, and if we do not find the respective key, for example if I write case 8 in here, then it will throw an error saying that there is no 8 in the dictionary because we have not defined 8. Now invalid input, because what dictionary.get does is that it gets the value of the respective case is respective key, but if that key does not exist, then it will print the following output. Now let's try that. Invalid input because there exists no case 8. Now if I do 7, then it should print case 7. Yeah, so we have implemented a switch, custom switch, and this might be useful for some of you if you want to implement a switch case statement. The next thing that we should be focusing on is something called loops. So what a loop does is that it just loops around. We will discuss about loops in detail tomorrow. Okay, so I think that's it for today. We have learned about if else statements, use of indentation, proper use of indentation when you are using what do you say, those nested ifs, how to use proper indentation inside an if statement which is already inside an if statement. Okay, and we also learned how to make our own switch case, which is this. Okay, so guys, that's it for today. I hope you like that. I was a little bit sloppy today, but it's time to end the stream now. So keep learning. Peace.